Hello and welcome back to Summer Work Help for Calculus 1. In this video, we're going to be taking a look at question number 10. So question number 10 says, let f of x equal 3x plus 5 and g of x equal x squared minus 1. Evaluate, then simplify. So for 10a, we're being asked to evaluate g of 2. All right, so for this problem, pretty straightforward, just an evaluation of the function. So this only deals with the g function. And the g function, what it says is it indicates that our input is represented by x, and it's saying take that input, square it, and then subtract 1. Right? That's the rule for the g function. So if I want g of 2, what I'm going to do is I'm going to basically rewrite the rule that's to the right of the equal sign for g of x. I'm going to rewrite this part, and everywhere I see an x, I'm going to replace that with a 2. So right off the bat, I run into an x, so that x becomes a 2. I square that, and then I subtract 1. All right. So this is a quadratic function. So 2 squared is 4, 4 minus 1 is 3, and that is my final answer for 10a. All right, great. 10b. Now, 10b is a composition of functions. So this one involves both f and g. The way that we say 10b is we say f of g of 2. All right. So the g function is inside the f function, and the way that we can evaluate this is we're going to work from the inside out. All right. So like I said, the g function is inside the f function. So what we're going to do is we're going to, like I said, we're going to work our inside out. So we're going to leave the f function alone for a second. All right, so f of, notice I haven't changed anything yet. So this is f of g of 2. Well, first of all, we just found g of 2, but I'm going to do it again. So the inside, this piece right here, is saying, what happens when you take 2 and you plug it into the g function? The g function says take your input, square it, and subtract 1. So again, we just found it for 10a, but I'm gonna do it again as if we did not just find it. So for g of 2, I'm going to apply my rule, and everywhere I see an x, I'm going to replace it with a 2. So again, right off the bat, you run into a 2, and we square that, subtract 1, and that is g of 2, right? And then I'm going to put a closing set of parentheses here for this outer sort of like f function. Okay, so I still have my f of. I simplify what's inside the parentheses. So 2 squared is 4. 4 minus 1 is still 3. Right? That's the same 3 that we got for 10a. However, unlike 10a, we're not done, because now what I have is I have f of 3. So that 3 was an output. It was the output of the g function, right? When you plug a 2 into the g function, you get a 3. So it was the output. But now what happens is we sort of immediately turn that around, and what was an output now becomes an input into the f function, because I want f of 3. All right, so we're taking our result and we're just plugging it right back in this case, into the f function. So the f function right here, again, we're indicating that our input is x, right? And we're saying take that input, multiply it by 3, and add 5. That's what the f function does. So I'm going to rewrite the right-hand side of my equal sign for the f function, and everywhere I see an x, I'm going to replace it with my input, which in this case is 3. So I have 3, and then it's 3x. So now this is where I'm going to plug in my 3 that I just got, and then I add 5. I'm going to simplify. 3 times 3 is 9, not 6 that I had originally, but 3 times 3 is 9, plus 5 is 14. And that is my final answer for 10b. F of g of 2 simplifies to 14. 10c. Now, on some level, 10c is actually the same thing as 10b, right? Structurally, it's the same thing, right? I have in 10b, I had f of g of something, and in 10c, I have f of g of something. So if you don't understand b, you're not going to understand c. So you definitely want to make sure that you understand what we just did in 10b, because with 10c, we're going to do, quote, the same thing. The only difference is that with 10b, I wanted to know, well, what happens, when you plug in a 2, right? For 10c, I don't want to plug in any specific number. I basically want to get a new rule for this new function, right? F of g of x is another function. It's not f, it's not g, it's f of g. And at the end of the day, because we're plugging in an x, we're going to get some rule involving x that is just, it's like a more abstract version of 10b, but conceptually it's actually the same thing. So just like with 10b, we're gonna work from the inside out. All right. So I'm going to ignore the f function for a second, and notice the inside here says g of x. Well, I know what g of x is. G of x is this, right? G of x equals x squared minus 1. So my first step for 10c is I'm going to rewrite what's on the inside, which is, in this case, g of x. So I'm going to replace g of x with what g of x equals, which is x squared minus 1. Notice that with 10b, I did the same thing, right? I did 2 squared minus 1. Well, now I'm just doing x squared minus 1 because I want g of x, not g of 2, right? Now, unlike 10b, I can't really simplify this, right? With 10b, we did 2 squared minus 1, and 2 squared minus 1 is 3. But now with 10c, I have x squared minus 1. Well, I can't really simplify that anymore. X squared that's a quadratic term, and 1 is a constant. You can't combine x squared and 1, so you just have to kind of leave it like that, all right? So now what we're going to do is we're going to now evaluate the f function. Now, this is the part where I see students get kind of tripped up, and the students do get this eventually, but sometimes it just takes a bit of time. So I'm going to zoom in here on the f function. So students are commonly see this notation, see f of x equals something, right? But what's really happening here is you've got f of something, right, equals 3 times something plus 5, right? That something could be an x, right? That something could be another letter, could be f of t, right? Could be another symbol, could be f of theta, right? So here, I'll say this as I'll write this, right? It could be f of t, right? Which would then be 3t plus 5, right? It could be f of theta, and then it would be 3 times theta plus 5, all right? But it can also be something like f of, let's say, a plus b. Well, in that case, if it was f of a plus b, then it would be 3 times a plus b plus 5. Clean that up a little bit. So a plus b plus 5. Right? So that x is just a symbol that represents your entire input, but your input could be a binomial, a trinomial, it could be anything, right? So when you have, I'll zoom back out here. So when you have something like f of x squared minus 1, well, x squared minus 1 is your input, and the rule tells you what to do with your input. The rule says take your entire input, whatever it is, multiply by 3, and then add 5. So what I'm going to do is when I evaluate this, I'm going to evaluate f, and everywhere I see an x in this equation, right? Everywhere I see an x, I'm going to replace it with my input, which in this case happens to be x squared minus 1. All right. So the first thing I run into is a 3, so I'm going to write that, and then I run into an x. So I'm going to replace that with what my input is, and my input here is x squared minus 1. Now, crucial. When you plug in the x squared minus 1, when you do this, okay, you have to include parentheses, okay? If you do not include parentheses, it is wrong, period, All right. We can be kind of flexible with some things, right? But this is one of those things that we can't be flexible with. When you plug in a binomial or a trinomial or basically anything other than a monomial, you have to include parentheses. Now, we also include parentheses like here, right? That was a monomial. Two is a monomial, and we included parentheses there, which wasn't strictly necessary. But with a binomial or more, you have to include parentheses in this case because the 3 is getting multiplied to the entire input, not just x squared, but x squared minus 1. All right? And then plus 5. Okay, so now all I have to do is just clean this up a little bit. So I distribute the 3, and I get 3x squared minus 3, right? Not minus 1, but minus 3, and then plus 5. And then I can combine like terms, giving me 3x squared. Negative 3 plus 5 is 2. And that is my final answer for 10C. Now notice, as predicted, we have a new rule, right? So this is a new function, all right? You can give it a name. It could be like h of x, right? Or just leave it as f of g of x, whatever. But we have a new rule. And then also notice that if we take our rule, okay, if we take our rule and if we plug in a 2, right? If we plug in a 2, we get 3 times 2 squared plus 2. All right. 2 squared is 4. 4 times 3 is 12. And 12 plus 2 is 14, which, oh, by the way, matches what we got for 10b, right? So you could just sort of get your rule first and then evaluate the rule at 2, and you should get the same answer that we got for 10b. Okay. 10d. 10d is similar to 10c. The only difference now is that the sort of like the order is reversed, right? So for 10c, we had f of g of x, and now for 10d, we have g of f of x. And spoiler alert, the order does matter, right? So we are not going to get the same answer for 10c that we got for 10d. Sometimes you might get the same answer, but chances are you won't, right? And in this case, you won't, or we won't. So, but we're going to apply the same sort of general concept to what we did for 10c and for 10b for that matter. So for 10d, we have g of f of x. And again, this part doesn't change. We're going to work from the inside out. So that means that g, we're going to leave the g alone for a second. All right, so g of. Now, inside, right, I have f of x. Well, I know what f of x is. I'll get rid of this too. So f of x is this. 3x plus 5. So I'm going to replace my f of x with what it is, which is 3x plus 5. Okay. Now, if we were evaluating this at a number, like 6, right? If it was like g of f of 6, well, we would plug in a 6, and then we would simplify the resulting term. It would be 3 times 6, which is 18, plus 5, which is 23, right? So at this point, we would be at g of 23. But we're not evaluating it at a given point. We're trying to get a rule for all values of x. So we kind of have to leave it as 3x plus 5, and you can't combine those. So now I'm going to evaluate this function, the g function, with my input of 3x plus 5. So what I'm going to do is I'm going to rewrite the g function, which is right here, okay? And it's saying that take your input and do this to it, right? Square your input and then subtract 1. So now if my input is 3x plus 5, what I'm going to do is everywhere I see an x, I'm going to replace that with a 3x plus 5. Well, with the g function, it's the first thing you run into. It's just x squared, right? And again, just like for 10c, we are plugging in a binomial. You have to include parentheses, like that, all right? If you do not include parentheses, you will get the wrong answer. It will be marked wrong. Now, the g function says take that input and square it, and then subtract 1. Great. So now I just want to simplify this, clean it up a little bit. So I'm squaring a binomial. This next step is not strictly necessary, but if you if you're kind of prone to errors, or if you feel like you still need a little bit of support here, I would recommend writing it out like this, because this is what it means when you square something. You multiply it by itself, right? Minus 1. And the reason why I would recommend you write it out is because now it makes it, perhaps a little bit more clear what we need to do here. We have a binomial times a binomial. Well, that's just a classic FOIL question, right? And FOIL is just the distributive property, right? FOIL is not like a technical math term. It's just like this mnemonic that we use in school to like learn what to do. So technically what we're doing is we're doing the distributive property 4 times, right? But FOIL, of course, is first, outer, inner, last. So first, we have 3x times 3x. So 3 times 3 is 9, and x times x is x squared. Outer is 3x times 5. So yeah, 3x times 5. So 3 times 5 is 15, and we have a single x. Inner is 5 times 3x. So 5 times 3 is another 15, and another x. And then last is 5 times 5, which is 25. Okay. If you make the mistake of, if you make this mistake, if you say, 3x plus 5 squared, if you just distribute like this, right? If you say that, that's wrong, okay? Because you're missing the outer and inner terms of FOIL, right? So the squared does not just distribute down to both terms, because then you're missing the outer and the inner. And then minus 1. Almost forgot that. All right. So last step here, we just have the single squared term. We have 2 linear terms. And then 25 minus 1 is 24. And that's a 4. And that is my final answer for 10D. And that's question 10.